In this vlog, we are delving into a groundbreaking shift in GPU architecture energized by AI advancements. This shift is steering the focus of performance architecture titans like Intel, AMD, and NVIDIA toward the innovative concept of Ghiplet. This transformative approach is poised to revolutionize the design, fabrication, and performance of graphics processing units by leveraging the power of artificial intelligence. Let us navigate through the technical intricacies and the professional narrative Ghiplet encapsulates, with AI as our central theme. At the core of the Ghiplet innovation is the modular design principle. Unlike traditional monolithic GPU architectures, Ghiplet proposes assembling GPUs from several specialized Ghiplets. This paradigm shift towards a more flexible and scalable performance-oriented computer architecture is fundamentally driven by the burgeoning demands of AI applications. By enabling the combination of Ghiplets dedicated to specific functionalities, be it processing cores optimized for AI computations, memory interfaces, or AI accelerators, Ghiplet architecture promises GPUs that can be custom designed to excel in a variety of AI-driven tasks, from deep learning to real-time analytics. The pivot towards Ghiplet is not merely a design preference. It is a strategic response to the manufacturing and efficiency challenges accentuated by AI's computational demands. The fabrication of large monolithic dies is fraught with inefficiencies and higher defect rates, issues that Ghiplet architecture mitigates by employing more diminutive, more manageable Ghiplets. This approach boosts manufacturing yields and ensures that individual Ghiplets can be replaced if found effective, dramatically reducing waste and enhancing production efficiency, a critical factor in an era where AI's appetite for computational power is ever increasing. Crucially, Ghiplet technology heralds a new era in interconnect technology, spurred by the need for high-speed, efficient communication between Ghiplets. A necessity underscored by AI applications. Innovations in silicon photonics and advanced packaging solutions are already at an advanced stage, aiming to meet the low latency and high bandwidth requirements of AI-driven computing. These advancements in interconnect technology are essential not only for the feasibility of Ghiplet GPUs but also for pushing the envelope in semiconductor design and fabrication at large. What stands out in the Ghiplet narrative is how AI is not just an application but a catalyst for innovation. Intel, AMD, and NVIDIA's embrace of Ghiplet architectures signifies a strategic alignment with the future of computing, where AI's role is central. This shift towards modular, Ghiplet-based designs is a testament to the industry's commitment to addressing the escalating demands of AI, ensuring that future GPUs are more powerful, efficient, and adaptable to the rapidly evolving landscape of AI technologies. The journey towards Ghiplet technology, underscored by the imperatives of AI, represents a pivotal moment in the semiconductor industry. It epitomizes a forward-looking approach where GPU architectures are designed better to serve the complex, diverse, and changing needs of AI-driven applications. As the semiconductor industry's key players lead this transformative movement, the promise of Ghiplet technology stands as a beacon for the future of GPU design and manufacturing, heralding an era where AGI can be fully unleashed, marking a new chapter in computing innovation.